Hey guys, how's it going? Mr. D here, back again with another video on Chapter 5. This one is going to be on Section 5.5, okay? And as you guys can see from the title, we're actually going to be looking into real-world applications of the things that we've been learning, which are systems of linear equations, okay? So our goal today is to be able to model a system of equations in a real-world application, meaning from a real-world scenario, we're going to actually try to write equations that we can use as a system in order to solve and find out what values will actually meet our criteria. But let's just go ahead and start practicing a little bit here, and we can apply some of the stuff that we've been learning. So let's go ahead and take a quick look at example number 1. So let's go ahead and read it and see what's being asked to do. So it says, you and your brother go to finish line and buy some flip-flops and socks. Excuse me. You buy 3 pairs of flip-flops and 2 pairs of socks and spend $78. Your brother buys 2 pairs of the same flip-flops as you and 4 pairs of the same socks, and he spends $60. What is the cost of 1 pair of flip-flops and 1 pair of socks at finish line? So as you guys can already see, we already have some info here, and if we notice this stuff right here in bold lettering, that's probably going to be important, and sure enough, it is, because the first thing that is being asked is to define what my variables will be, my x and my y, and as you guys can probably already figure out from the problem, it looks like x will be a pair of flip-flops, and we'll call y a pair of socks. Okay, so x is my yellow, y is my green. Okay, so those are our two variables, and if you guys notice back in the problem, if you reread it again, that's really what we're talking about. We're talking about buying flip-flops and socks. But now we actually want to go ahead and go a step further and talk about um, an equation. We need to be able to set up a system of equations to represent this entire scenario. So the first thing that's being asked is, excuse me, it's being asked to write an equation for your purchase. Okay, well, let's go ahead and reread the problem and look at my purchase rather. Okay, it says you buy 3 pairs of flip-flops and 2 pairs of socks and spend $78. Okay, but we know what flip-flops are. We know flip-flops are X, and we know that socks are Y, and then we spend a total of $78. So from that, you guys have probably gathered already that I can write an equation such as this. 3x plus 2y equals the amount of money I spent, which in this case is $78. Okay, so hopefully you guys were able to gather that information from our scenario here. Now let's go ahead and take a look at what our brother's purchase would have been. Okay, so it says your brother buys 2 pairs of the same flip-flops and 4 pairs of the same socks, and he spends $60. So everything there in purple we should be able to write an equation for. So that would be 4x plus, let's see, oh, sorry, it would actually be 2x plus 4y equals 60. Okay, so let's go ahead and see what part C is asking. It says solve the system of equations from part B to determine the cost of each pair of flip-flops and socks. Okay, so now we have our two equations here. We have our first one and our second one. We're going to actually go ahead and solve from here. So we have 3 methods of solving, as we can remember from before. We can graph, we can substitute, or we can eliminate. Okay, so substitution, elimination, or graphing. From this scenario, I can already see that I want to go ahead and try elimination, but you can try whichever method you want. Okay, but I'm going to go ahead and try elimination, so why don't I go ahead and rewrite my equations here. Okay, and then my second equation, Okay, so I have my two equations there. Now I have to eliminate something. So as you guys remember from before, look at your x's. If I add those, will they cancel each other out? Nope. If I add these two, will they cancel each other out? Nope. Okay, so then more than likely we're going to have to multiply one of these equations. Okay, so then you ask yourself, are any of these already a positive and a negative? Well, the two x's are both positive and the two y's are both positive, so no hint there. But now you got to ask yourself, can I turn the smaller of the two variables into the higher of the two variables? Okay, so you ask yourself, can I turn this 2 into that 3 by multiplying it by something? Well, no, there's no whole number that can be multiplied by 2 to get a 3. So I'm going to step away from the x for a second. Let's ask the same question about the y's. Can I turn that 2, which is the smaller of the two numbers, into a 4? Yeah, I can turn the 2 into a 4 if I just multiply it by 2. Okay, so let's go ahead and do that. I'm going to multiply the whole thing by 2, but not only just by a 2, by what? Remember, I want these to cancel each other out. So the opposite of a 4y is a negative 4y, so I want to multiply the whole thing by a negative 2. So let's go ahead and figure out what that would be. Okay, I'm going to distribute. What do I get? I get a negative 6x minus 4y equals a negative 156. And then down below, I'm going to go ahead and rewrite the same equation. Now I can go ahead and add here. Okay, so I'm going to add the two columns. So this would be a 4x. These two would cancel. And this would be a negative 96. Last step here is to divide by a 4. So what do we get? We would get x equals a negative 24, if I'm not mistaken. X equals a negative 24. Well, right away I can tell I did something wrong because I can't have a negative price. So let's see what I did here. And it looks like this is what I was missing right there. Okay, a negative 6 plus 2 is a negative 4. So I have to divide by a negative 4. Now I've corrected my problem. So my real answer is just 24. Okay, so what is my cost per flip-flops or per X? Well, that would be $24. Okay, notice what happened there, guys. I thought I had my work correct, but then all of a sudden I noticed that I had a negative answer. And what we're talking about here is money. So how could you possibly pay negative amount of money? Okay, you can't. So right away I knew I did something wrong. I rechecked my work and I made sure that everything was correct, and lo and behold, I did have a missing negative. So now we have the correct answer and we can move on to the next part, which is to find my y. Okay, I found my x, now I have to find my y. So let's go ahead and enter that 24 in for x for one of my original equations. I'm going to go ahead and do it to the bottom one. So this would be 2 times 24 plus 4y equals 60. Okay, so what would that be? That would be a 48 plus 4y equals 60. Subtract 48 from both sides to get the y out by itself. So 4y equals 12. And right away, obviously, I need to get rid of that 4 as well. So my final answer here is y equals 3. And since we're talking about money here, or cost, we know that has to be in dollars. So the cost of socks in this case would be $3. And again, guys, if you ever wanted to confirm that, remember that you can always enter that back into the original equation, on both of the original equations actually, and you should get a true statement. Okay, so let's go ahead and practice one more time with problem number 2, and then I'm actually going to have you guys try out number 3 on your own. All right, so let's go ahead and look at example number 2. It says, and before I even start reading it, guys, make sure you start paying attention to what it is that we're looking for. What things are they asking us to do? Okay, so let's see. It says Ashley and Lindsay are selling flowers for a school fundraiser. They are selling packages of tulips and Gerber daisies. Sorry. Ashley has sold 6 packages of tulips and 5 packages of Gerber daisies for a total of $150. So right away I can already start to see my first equation. Okay. Now it says Lindsay sold 12 packages of tulips and 11 packages of Gerber daisies for a total of $318. It says, what is the cost of 1 package of tulips and 1 package of Gerber daisies? So right away I can tell what my variables are going to be. We'll go ahead and call this one my x, this one my y. So my x is tulips and my y is Gerber daisies. And I guess more specifically, guys, we're talking about the cost. Okay, so I guess you can say cost of, cost of. Okay, so the cost of tulips and the cost of Gerber daisies. Okay, let's go ahead and try to write down our equations. So let's do a little bit of highlighting here. Okay, so let's see what 2 scenarios we're talking about. Well, we're talking about Ashley's sales and we're talking about Lindsay's sales. So let's go ahead and look at Ashley's sales. So it says Ashley sold 6 packages of tulips, okay, and actually 5 packages of Gerber daisies for a total of $150. So that is my first equation. So I have 6x plus 5y equals 150. Okay, next up is Lindsay's sales. So Lindsay sold 12 packages of tulips, 11 packages of Gerber daisies, for a total of $318. So once again, I can write my new equation. This would be 12x plus 11y equals 318. All right, so I have my 2 equations, and hence now I have my system. Okay, so now it says solve the system of equations from part B to determine the cost per package of tulips and package of daisies. Well, once again, guys, let's start asking ourselves, can I add these 2 for them to cancel out? No, that would be at positive 18. Can I add these 2 and have those cancel out? Well, no, that would be a positive 16. Okay, well, next thing I usually ask myself is, are one of these positive and negative? So are they already exact opposites? Well, no, we have a positive 6 and positive 12, so both are positive, so no on that one. And then on my y's, I have a positive 5 and a positive 11 also, so yet again, a no on that one. Now, my final thing I would ask myself is this. Can I turn the smaller of the 2 into the bigger of the 2? So basically, I'm saying between the 6 and the 12, which one's smaller? Okay, the 6 is smaller. Is there any way I can multiply 6 by anything to get a 12? Or more specifically, a negative 12, so they will cancel out? And yeah, you guys are probably already thinking, okay, negative 2. So let's go ahead and do that. I won't even check the y's here. If I can find one right away, there's no reason I should need to check the other one. Okay, if I multiply that whole thing by negative 2, it'll work. So why don't I actually go ahead and retype my 2 equations here, so I can leave my original equations intact over here on the right hand side. So all I'm doing is rewriting my original equations, I should say. Okay, so 12x plus 11y equals 318. Okay, and we said that we can turn that 6 into a negative 12 by multiplying everything by a negative 2. So what do we get? We should get a negative 12x minus 10y equals negative 300. And my bottom equation, no need to change it. So I'm going to rewrite it. I can now officially add these up. So those two columns would cancel each other out. Negative 10 plus 11 is a 1y, or just y. And then negative 300 plus 318 is just 18. And look at that. We already have the y all by itself. So this is my answer right here. And actually, let me double check something real quick. Okay. So this right here is my y. So let's go ahead and check back up here. What was my y again? Y was my cost of Gerber daisies. So we would say here on the side, cost of Gerber daisies equals $18. Okay, but that's not all I want. I want to also know how much the tulips were. Okay, so let's go ahead and figure that out. So once again, all I have to do now is substitute this y into one of my original equations. So either there or there, whichever one I decide. I'm going to go ahead and use the top one since those are smaller numbers, and I'm sorry about that, but my computer's acting up a little bit. All right, so I'm going to actually substitute it into the smaller one, or sorry, the bottom one. I don't know, what am I talking about? I'm sorry. I'm going to actually do the top one because that one has smaller numbers. The smaller the numbers, the better. Okay, so I'm going to go ahead and do 6 times x plus 5 times 18 equals 150. Okay, but again, it doesn't matter which one you use, but I'd like to use the top. So this will be 6x plus 90 equals 150. Let's get rid of that 90. So we get 6x equals 60. Final step here, divide by 6, divide by 6. So we get x equals 10. So what is my cost of tulips? That would be $10. Okay. So my cost of Gerber daisies is $18. Cost of tulips is $10. Okay, so this is cost per package of Gerber daisies and cost per package of tulips. Okay, so again, what did we do? We looked at the scenario. We were able to identify what our variables were. In this case, they were my x and y, which were my Gerber daisies and tulips. Okay, then we were able to identify what each equation how each scenario could be modeled. So in this case, it was Ashley's model, right? Ashley's model was this right here, 6x plus 5y equals 150, and then Lindsay's model was this one right here. Okay, those two models just gave me a system. Okay, they're a set of linear equations. From there, we knew we had 3 skills that we now know. We can either do elimination, substitution, or graphing. Well, there's no graph here, so I'm not even going to try graphing here. And substitution you could do, but it's going to be a little bit harder to isolate one of those variables in order to substitute it into the other equation. So what I went ahead and did was just use elimination. So that's the process I used here if you wanted to know. So that's what I tried. I did elimination, and I don't know why that crossed out. I'm supposed to highlight it here. I did elimination. Okay. All right, guys. I think that's enough of me talking for a little bit. So what I want you guys to do is try out number 3 on your own, and we will come back to verify that you have your correct answer. Let's go ahead and pause the video right now and give that a shot. All right, guys, let's go ahead and talk about example number 3. So it says Lori and John are selling their pies at an Italian bakery. Customers can buy either their cherry or apple pies. Lori sold 6 cherry pies and 2 apple pies for a total of $46. John sold 12 cherry pies and 8 apple pies for a total of $136. Now it says, what is the cost of 1 cherry pie and what is the cost of 1 apple pie? Okay, and again, my computer is being annoying. So let's see if we can figure this out. Okay, so it says define your variables. Well, the first one that I can definitely say is that I have 1 cherry pie. So we're looking for a cost. So the variable x, I'm going to go ahead and call it cost of 1 cherry pie. Okay, and then my y is going to be cost of 1 apple pie. Sorry about this, guys. This is probably the only way of getting my computer to work, so never mind me for a second here. Okay. All right. So let me rewrite this. Hopefully it works now. So cost of 1 cherry pie, cost of 1 apple pie. Okay, there we go. All right. So let's go ahead and go through the same process. So we've defined our variables. First thing is done. Next thing is to identify both different scenarios to verify and to actually create and model our linear equations to set up our system. Okay, so it says Lori sold 6 cherry pies and 2 apple pies for a total of $46. And then John sold 12 cherry pies and 8 apple pies for a total of $136. So yet again, we can go ahead and set up our 2 equations for our system. Okay, so let's go ahead and set that up. So in green, I can see already I have 6x plus 2y equals 46. That's my first equation. And then the equation that John is modeling would be 12x plus 8y equals 136. All right, we have our system. Now we have to decide we're going to use graphing, substitution, or elimination. Well, as you guys can see here, there's nothing all by itself, like nothing that says already x equals or y equals. I probably don't want to use substitution. Okay, graphing, again, we don't have 2 things in slope-intercept form, so probably graphing wouldn't be the best idea. So we're gonna we're gonna try to resort here to elimination, just like we did in the past 2 problems. So let's go ahead and figure that out. So again, I like to always kind of highlight these, because remember, we're adding the columns, guys. So if something adds already and it will cancel one of the variables out, then that would be ideal. So let's verify. The 6 and the 12, would those cancel each other out? No, they're both positive, so they don't even have alternating signs. So that's not going to help us. What about the y's? A 2 and an 8, those are also both pluses, and they would add to be a positive 10, so they would not cancel each other out. So we are going to have to multiply one of these things, or one of these equations, by some number. So as you guys can remember from my previous videos, I always ask myself, well, can I turn the smaller one, like for example in my x's, my smaller one here would be my 6. I ask myself, can I turn that smaller one into the opposite of the bigger one? Okay, well, my bigger one here is 12, so can I turn 6 into 12 by multiplying it by something? Well, yeah, I can. I can multiply it by 2. But more specifically than that, I don't want to just multiply by 2. I want to multiply by a negative 2 because I want to turn that 6 into the opposite of a positive 12, which in this case would be a negative 12. All right, so let's go ahead and distribute that out, see what we get. So I'm going to go ahead and do that here on the side. So that would be a negative 12x minus 4y equals a negative 92. And then my other equation would be exactly the same. There was no need to change it. Okay, now I can go ahead and add my columns. These, if I add them, it will just turn into 0, so they cancel each other out. Negative 4y plus 8y is a positive 4y. And then negative 92 plus 136, if I am not mistaken, that is a 46, I want to say. Nope, that can't be right. Not 46. That would be a 44. I believe that's right. Give me a second, guys. I don't have my calculator on me. That'd be 36 plus 8. So that would be, yes, 44. Okay, good. All right. So next thing, what I want to do, I want to get the y by itself, so I have to divide by 4. So we get finally y equals 11. All right, so I have y equals 11. And what did y stand for? Well, y stood for the cost of one apple pie. So that would be actually down here, the cost of one apple pie would be $11. Okay. All right, let's go ahead and do the second part, which would be the x. Okay, well, all I have to do now is go ahead and substitute that into that y into one of my original y's and one of my original equations. Okay, I'm gonna actually choose this top equation, guys, just because the numbers are a little smaller. Let's go ahead and do that. So I'm gonna go ahead and do 6x plus 2 times 11 equals 46. Okay, this would be a 6x plus 22, 46. Let's get rid of that 22 to get 6x equals, that is a 24. And then finally, divide by 6, so I get x equals 4. Okay, so the cost of one cherry pie would be $4. Okay. All right. So I sincerely hope that this is starting to make sense, guys. Like I said, if you ever wanted to make sure that you did this correct, all you really have to do is put those two values back into the original equations, okay? And you know what? For the sake of it, I'm going to actually try it out with one of these equations. And again, if these two numbers are correct, then the answer that I get in the very end should be a true statement. So why don't I actually do that? I'm going to do 6 times 4. Okay, so again, I'm testing out my top equation. So 6 times 4 plus 2 times 11 should equal 46 after I'm done. So let's see, what is this? This is 24. What is this? This is a 22. Then if I add my 24 plus 22, that is a 46 equals a 46. Is that true? Yes, of course it is. So that is correct. And again, if I wanted to make even more sure that I did this correct, test this one out, okay? Test out that next equation and you should still end up with a true statement. All right, guys, I think we only have one more to go, so why don't we go ahead and take a quick look at that one, and then we will be done with this video. All right, so I hope that you guys got number 3 right, because I'm actually going to ask you guys to try out number 4 on your own for a second. So why don't you guys go ahead and pause the video, and we will come back to verify that you did it correct. All right, so let's go ahead and read the scenario. So it says, Tina and Amanda are selling cookie dough to raise money for the Addison Trail gymnastics team. You can either buy buy packages of chocolate chip cookies or packages of gingerbread cookie dough. Okay? So Tina sold 8 packages of chocolate chip cookie dough and 10 packages of gingerbread cookie dough. and raised a total of $236. Amanda sold 5 packages of chocolate chip cookie dough and 5 gingerbread cookie dough for a total of $125. What is the cost of one package of chocolate chip cookie dough and one package of gingerbread cookie dough? So this looks like my first variable. This looks like my second variable. So let's go ahead and write both of those down. So my cost of chocolate chip will be X, cost of gingerbread will be Y. So cost per package of chocolate chip cookie dough. Okay, and then Y will be cost per package of gingerbread cookie dough. Okay, so cost of one box of cookies of chocolate chip and then one box of gingerbread. Okay, so let's go ahead and read through our scenario one more time to identify our two equations. So we see that it says, let's see, Tina. Okay, so Tina sold 8 packages of chocolate chip cookie dough and 10 packages of gingerbread cookie dough for a total of $236. So that is my first equation. I'm going to go straight to writing that so I don't forget it. Okay, so that would be 8x plus 10y equals 236. All right, next scenario. We have Amanda. So Amanda sold 5 boxes of chocolate chip and 5 boxes of gingerbread for a total of 125. So yet again, 5x plus 5y equals 125. Okay, cool. So again, let's go through the motions here. So can I add these two right away to cancel each other out? No. Can I add these two right away to cancel each other out? No. Okay. Well, that didn't help us. So let's go ahead and try out this. So next thing what I want to do, and again, I'm using process of elimination here, guys. So we're going to try to see if we can eliminate one of these to get one of the variables all by itself. So my next thing in my list was always double check the smaller number to see if you could turn it into the bigger number. So can I turn that 5 into an 8 by multiplying it by something? Nope, can't do it. So I'm going to go ahead and see if I can do it for my y's. So again, which one's bigger? Or sorry, which one's smaller, the 5 or the 10? Well, the 5's smaller. So can I turn that 5 into the opposite of that 10? Well, yeah, if I multiply it by 2. Okay. So what I'm going to do here is I'm going to multiply this whole thing down here by 2, but I want the opposite of a positive 10, so it's going to be a negative 2. All right, so let's go ahead and distribute that out. So let's go ahead and rewrite the equation. And my bottom equation, now I get negative 10x minus 10y equals a negative 250. I can add these now. Well, 8x plus a negative 10x is a negative 2x. These two cancel. And then 236 plus a negative 250 is a negative 14. So, last thing I need to do here is divide by a negative 2 to get a final answer of x equals a positive 7. And we know that x means right here the cost of a package of chocolate chip cookie dough. So for that space right here, I'm going to go ahead and write $7. Okay, so each package of chocolate chip cookie dough costs $7. Now to find my cost of gingerbread, I just have to take this and either substitute it in here for that x or in here for that x. whichever one I decide. I always like to choose the one that has the smaller numbers. So the equation that has the smaller numbers here looks like the bottom one. So that's what I'm going to use. I'm going to do 5 times 7 plus 5 times y equals 125. So this is 35 plus 5y equals 125. Subtract 35, subtract 5, get 5y equals 90. Finally, divide by 5, so we get y equals 18. Okay, so it looks like my gingerbread cookies will cost $18. Okay, and yet again, guys, if you want to confirm, which is probably a good idea, okay, because I'm not exactly sure why chocolate chip costs $7 and gingerbread costs 18. That looks like it's completely off. Well, let's go ahead and confirm it, okay? We can always do that. That's the power of what we're doing here, okay? So I'm going to do 5 times 7 because X was $7. And then 5 times, we just found out that it was 18, okay? So this was 35 plus 5 times 18 is a 90. And let's see, 35 plus 90, that is 125. So is 125 equal to 125? Yes, it is. Okay, again, just for the sake of checking, now I'm going to check this one. Okay, so that would be 8 times x, which was 7, plus 10 times 18, which is my y. And I should get 236. Let's see. 8 times 7, that's a 56. 10 times 18 is a 180. And what is 56 plus 180? Well, that is 236. So look at that. They both worked. As soon as you know that both work, then you definitely have the correct answer. Alright guys, I think that is it for this video. The next video, I'm not sure right now what the next video is, but I'm sure we will continue on with applications of linear equations as well as systems and possibly even a little bit of systems of linear inequalities. Okay, so I think for right now, you guys can go ahead and stop the video and move on to the next one. Alright guys, I will talk to you soon. Bye.